Hey guys, welcome back to my YouTube channel. Today we are going to learn how to find the solution of this differential equation, and also we have to find the solution given this initial condition. We have to satisfy this initial condition at the same time. So to do this, first we have to solve this differential equation. So to solve, we have to get all the y's on one side, all the x's on one side, right? Because we can basically separate this. It's a separable equation, right? Separable differential equation. So in this case, we are going to put all the x's on one side, all the y's on one side, and the easy way to do this here is we can cross multiply. So crossing multiply, we have our x's together, so 5x squared and dx. We're going to write that together like this. And then we have ln y plus 1 and dy together, so we're going to write that together like this. And then now we just have to integrate both sides. So integrating both sides. And we're going to work on each side separately. So here we have a 5, we can bring this outside. So this would just be 5 times the integral of x squared. And then here, to integrate this part, we can use a substitution. So we can let w equals y plus 1, right? So y plus 1 right here. So we're going to let this be the case. And then what's going to happen is we can differentiate this, so dw over dy is going to be equal to 1, and then we have to multiply dy on this side, so dw equals dy, and we can substitute this dw into this dy right here, and of course y plus 1 is going to become w, so we're changing all these y's into w's. So here it's going to be ln w instead of y plus 1, so it's going to be w, and then dy is going to become dw, just like that. And then now we have to integrate these, so here, let's work on this side now. So 5 times the integral of x squared. Well, the integral of x squared, we are just going to have to add 1 to this exponent, and then whatever is here in the exponent, right, goes in the denominator. So 2 add 1 is 3, so that's why we get these 3's. And then to integrate ln w, it's a little bit more complex, but we basically integrate by parts. So to integrate by parts, the formula we have is integral of u times dv equals uv minus v du. So here we are going to have to set our u and dv, so let's make our u ln w in this case, because we know the derivative of this is going to be simpler, which is just going to be 1 over w, right? We want to make it simpler, so the u has to make it simpler, so the derivative has to be simpler, so that will help us. And then dv is going to be this part here. dv is going to be equal to dw. So here, this is, by the way, here du is going to be equal to 1 over w times dw, like that. And then we have v, we have to find v, right? V, we can see here dv is equal to dw, so dv is going to be equal to dv over dw is going to be equal to 1, like that. So we want to integrate this, and to integrate that we just have to take the variable, so v is just going to be w like that, because if we find a derivative of w, we're just going to get 1. That's why this will be w. And now we just have to substitute this in, so we have u times v, right? U times v, so u, what's our u? U in this case is ln w, times v, our v is w, so we just multiply by w, substitute that in, and subtract the integral of v, right? What is v? Well, v is w, so we just write w, and then du. What is du? Well, du is equal to 1 over w times dw. So 1 over w times dw. So we substitute that in, right, to get this part of the formula. And now it will make things simpler for us. So let's simplify this. This is 5 over 3x cubed. And then we can simplify this side as well. Just w ln w minus integral of, well, w and w cancel. It's just going to be 1. So we don't really have to write the 1. So just like this, right, integral of 1 is here. And then from here, we can integrate this. So 5 over 3 x cubed is equal to w ln w. We're just copying these, and then to integrate like a 1, we will just basically get w. Well, originally it's w to the exponent of 0, right? W to the exponent of 0. This is to the exponent of 0, and we want to add 1 here, and then we copy whatever is at the top, right? So that's why we will get w to the exponent of 1 over 1. So w to the exponent of 1 over 1, and that's just going to be w right here. So this is going to be equal to w. So that's how we get this part. And then we can see that we got this part, and we have removed all our integral signs. So this is just going to be, we have to add a c here, right? Because we have to add the constant after integrating. And then now we see that, oh, well, this is w's, right? So we want to change it back to y's. So we were using y's before. So what was w? Well, w is equal to y plus 1. So we are going to sub in y plus 1 every time we see a w. So here we're just going to copy these. So this is a w, so it's going to be y plus 1. This is a w, right? So ln y plus 1. This is a w, so y plus 1 and plus c, like that. And then now we pretty much have gotten our equation. But we are not done yet. We have to basically satisfy this initial condition. So here this is our x, right? Our x is going to be 0 and our y is going to be equal to 7. So we're just going to sub those in. So every time we see an x, we write in 0. So here we have an x, so we're going to write in 0 here. And we're going to sub in 7 for the y. So 7 plus 1, 7 plus 1 minus 7 plus 1 plus c. And then here we get 0, and here we get 8 ln 8 minus 8 plus c. And so we're basically solving for c, right? So we're solving for this c. We want to find out what it is. That's why we substitute these in, right, to satisfy the initial conditions. So here we're going to solve for c. And c, well, if we move these to the other side, it's just going to be negative 8 ln 8 plus 8 is equal to c. So c is equal to negative 8 ln 8 plus 8. And I want to make this law look better, so I'm going to recognize that 2 to the exponent of 3, right, is equal to 8. So I'm going to write 2 to the exponent of 3 like this, plus 8. And then I can take this out and multiply it with the 8. c is equal to negative 8 times this 3, which we take out, ln 2 plus 8. And then we simplify it, c is equal to negative 24 ln 2 plus 8. And then there we have it, we have our c. And now we just have to plug the c back into our equation, which was this equation right here. So we're going to plug that back in. So if we plug it back in, well, let's just copy this part first. 5 over 3x cubed is equal to y plus 1, right? We're not substituting anything in the y's now, or the x's now, because we just have to plug in the c, that's it, to get the equation. So ln y plus 1 minus y plus 1 plus c, right, the c right here, shown in this equation, so we have to plug in the c, and the c in this case is this whole thing, so we're just going to copy that. Negative 24 ln 2 plus 8. And then what I like to do is I would like to organize this a bit, so I'm going to basically expand this, right? I'm going to expand this, so expand this like that, as we can recognize that this is like distributive property, so I'm going to do that. I'm going to write the equal sign here this time. So it's going to be y ln y plus 1 times ln y plus 1 is just going to be ln y plus 1 minus y plus 1 and negative 24 ln 2 plus 8. And then I want to distribute this negative to each one, so I'm going to do that as well. So 5 over 3 x cubed equals y ln y plus 1 plus ln y plus 1 minus y minus 1 minus 24 ln 2 plus 8. And I see here I can combine this and this together, right, to get 7, so I'm going to do that. So it's going to be 5 over 3 x cubed equals y ln y plus 1 plus ln y plus 1 minus y minus 24 ln 2 plus 7, right, because we combine these two. And then I'm going to move everything to this side, so I'm going to move this term to this side, so it's going to be 0 here, and negative 5 over 3 x cubed plus y ln y plus 1 plus ln y plus 1 minus y minus 24 ln 2 plus 7. And I like to put my 0 on the right side, it looks better. So I'm going to reorganize that. Negative 5 over 3 x cubed plus y ln y plus 1 plus ln y plus 1 minus y minus 24 ln 2 plus 7. And I write my 0 on this side instead, right? So we kind of switch sides. And there we have it. So this right here is our final answer to the question. So whenever you are basically asked to basically satisfy an initial condition, like find a solution for this to satisfy this initial condition, the first step you have to take is solving the differential equation. And in this case, it's a separable equation, so that's why we use the method for doing that, basically putting all the y's on one side, all the x's on one side, right? And then this is the initial condition, so we have to plug in our variables for the initial condition, which is the x and the y, right? And plugging that in, we solve for c, and we solve c to be this right here, okay, or you can say this, and then we just plug the c back into our original equation, which was this with the arrow. We plug it back in, and once we plug it back in, we rewrote the equation, made it look nicer. Okay, so this is the end of the video. If you enjoyed the video, feel free to give it a huge thumbs up, and also let me know in the comments down below what you think about these type of math problems. And furthermore, if you are new to my channel and you enjoy my content, feel free to hit the subscribe button. Anyways, it was nice making this math video. I will talk to you next time in another one of my math videos. Bye!